Alright, part 4 asks you to write the equation given the graph. So as always, we know that the equation looks something like this. Y equals to a number maybe multiplying, right, the absolute value of x plus or minus something, right, and at the end also plus or minus a number. So that all depends on where the translation is from the origin, right, from the origin. So let's look. Well, from this point, here's our graph, and let's ask from this point to this vertex, right, from the origin to the vertex, did it go left or right? Well, no, right? It didn't go to the left, it didn't go to the right. So we don't add or subtract anything inside the absolute value with the x. So, okay, that's just absolute value of x. Now, our next question is, did the graph go up or down? Well, it went up. It went 1, 2, right? 2 units up. So, we add 2. Now, from this vertex, okay, we got to find the slope, okay? So, here's another point on the grid that is exactly on the corner. So let's see, rise 1, run 1. Well, the slope is just 1. So we could put a 1 there, but it's unnecessary. So really the answer is just y equals to the absolute value of x plus 2. Okay, number 8 asks you for an equation such that an absolute value function has a graph that is narrower than the graph of absolute value of x, and has an axis of symmetry at x equals to -5. Well, let's think about this. We know that, well, any equation, right, we know it should look something like this. Might be multiplying something, x might be plus or minus something, and then outside, behind, plus or minus something. Well, remember axis of symmetry, right? Our axis of symmetry is always x equals to a number. And it's at -5. So if I draw a graph, -5 is around here. And if this is our axis of symmetry, then it's splitting the absolute value in half. Well, let's look at this. Let's look at the graph. -5 is to the left. So how will we write that our graph from the origin shifted to the left 5 units? Well, we know it's x plus 5. Another thing is they say the graph gets narrower. If you remember in your notes, when the absolute value gets narrower, that's when it's multiplying, right, a number that is greater than 1. So you could put 2, 3, 4, right, as long as a number greater than 1. So this is our equation, y equals to 2 times the absolute value of x plus 5. For number 9, we're doing the same thing. It's asking for the function of y equals absolute value of x is translated 5 units to the right and 3 units up, and then the function is compressed by a factor of 4 and reflect across the x-axis. So this is a more intense question than the previous one, but it's the same process. We know that it's y equals to maybe a number multiplying absolute value of x plus or minus a number, and then at the end might plus or minus another number, right? Well, look at this. Translated 5 units to the right. Well, we know that inside, right, inside the absolute value is the horizontal change. And if it's to the right, we know it's opposite sign. So x minus 5. 3 units up, we know that's a vertical translation, up and down, right? That's, since it's up, it's a positive, add 3. then the function is compressed by a factor of 4. Now this one is opposite, right? It's opposite from the previous one where you put a 2. This was a vertical stretch, right? It gets narrowed. Now it gets wider. That means that our multiplying number has to be less than, right? Less than 1. So 1/4. Also, it's reflected across the x-axis. Remember, when it's across the x-axis, the negative is outside of the absolute value. So you get y equals negative 1/4 times the absolute value of x minus 5 plus 3. Number 10 asks you which transformation of the graph of f of x equals 4 times the absolute value of x minus 5 plus 2 create a function whose vertex is negative 5 comma negative 1. Now, there's a mistake here. I want you guys to change this negative 5 comma negative 2 to negative 5 comma 2. All right? Now let's look at this. I'll draw a graph. This is the original one. This is this. So it say up to, right, to the right 5. 1, 2, 3, 4, 5. All right, we're just estimating. So here's the vertex of this. Now it asks, okay, what type of transformation happens to the graph if the new vertex is negative 5 comma 2? Well, here's positive 5. Here's 2. Now negative 5 comma 2 is this way, right? Negative 5 comma 2 is here. So what happens? Well, it's just a reflection across the y-axis. So B is our answer. Number 11 asks you, what is the domain of y equals to negative 1/2 times absolute value of x plus 10 minus 6? Well, one way you can do this is you plug this in the calculator and look at the graph, or you can kind of manually draw it out, right? It doesn't have to be very accurate as long as you see the pattern. Well, plus 10 minus 6 means it goes down 6, right? Somewhere around here. Plus 10 means going to the left 10, right? I'm just saying, well, here's my vertex. Now, the slope is negative 1/2, so that means it's going down, right? It's going down. The arrows, they're pointing down. The lines, they're pointing down. And the domain is really all the possible x values. So, if it's pointing all the way to the left, even going down, it's going to the left, right? It's covering all of the negative infinity x. Pointing down to the right, it's still going to the right, so it's going all of the positive infinity possible x values. So it's just from negative infinity to positive infinity. For set notation, x, such that x is all real numbers. Alright, number 12 asks you what is the axis of symmetry of the following function. I believe the easiest way for me to find out is try to graph it, right? Try to draw a graph and then graph the function, and then you'll see where the axis of symmetry is. So let's start. This number says plus 6, so that means we go up 6. All right, let's say here's 6. And then x minus 4 means we go to the right 4. Okay, so 1, 2, 3, 4. So it'll be somewhere right here. Here's 4. And then it's a positive slope, so let's draw a general, right, general line. Now, let's look at this. The axis of symmetry is where well, imagine a line cutting the absolute value in half, right? So it'll be right here. Well, here we know that it's positive 4. So our axis of symmetry really is just x equals to 4. Alright, number 13 asks us to describe the transformation from the parent function y equals to absolute value of x to y equals the absolute value of x minus 5 minus 7. So I circled that negative 7 there, right? Everything outside of the absolute value, we know that's a vertical change. So negative 7 means it's going down 7. So we look at our answer choices. A says going down 7. B says going down 7. So we can automatically eliminate C and D. Now inside the absolute value is x minus 5. Remember, when it's x minus 5, right, inside the absolute value is always the opposite. Okay, so x minus 5 means we're going to the right 5. If we look at answer choice B, it says left 5. So we know that's wrong. So down 7 units, up right 5 units. Our answer is A. Alright, number 14 asks you to pick the graph of which function has the range of 3, positive infinity. So we know it's going from 3 to positive infinity. Let me draw a couple of graphs for you. Let's say this is one of the graphs. Okay. Here's another possibility, that is the arrow is pointing down. Now, if it says from 3 to positive infinity, well, we know that the arrows have to point up, right? We're looking at the range, it's up and down. So positive infinity means it's going up. So this negative, right, the graph that is pointing down, we know that's not possible. Now, if you look at your answer choices, right, positive 2, negative 2, negative 2. Well, remember, this number here, we say that it can represent a slope. So if it's a negative slope, doesn't that mean that it's going down? Right? Here's the same thing. So if it's going down, it doesn't go to positive infinity. We can cancel those out. Now we have two possibilities. One is plus 5 and one is plus 3. Now we know it's inclusive at 3. Well, let's think about this. Okay, which number? Right? Where would the 3 be if it's in range? Well, this 3 say is going up 3. Right? From the origin is going up 3. This plus 5 say from the origin is going up 5. Now, our range is from 3 to positive infinity. Well, doesn't that mean that here's the 3 all the way up to infinity? So our answer is B. You can also think of it like this. We know that numbers outside represent a vertical change. Okay? Vertical change. Now, the range, we know that's the change in y-axis. That's up and down. That's vertical. Right? So, here's 3. Here's 3. That's one way to look at it.